Hello everyone, welcome to my channel. In this video, I have two integrals that I would like to look at. The first integral is the integral of sec x tan x divided by sec x plus sec squared x dx. Now, looking at this, what would be the correct technique of integration to employ? Looking at the numerator, you can actually see that we have sec x tan x, and if you differentiate sec x, you get sec x tan x. And therefore, it would be a wise idea to let u be equal to sec x. As follows, taking us to page 1. So what do we have now? Let me capture the integral first. So we have integral number 1. It's the integral of sec of x tan of x, and we're dividing the whole of this by sec of x plus sec squared of x, and we have dx there. So what I was saying is, if we let u be equal to sec x, it means du will be equal to sec x tan x dx. And therefore, if we rewrite this integral, it will look as follows. The integral of, check this, 1 over sec of x plus sec squared of x. And what are we saying? We're multiplying this by, in brackets, sec of x tan of x, and then we have dx, like that. Now, maybe the bracket here, but it's fine the way I've written it. I want the bracket to be removed there because the whole of this is it's a product, so we don't need brackets necessarily. Now, basically, I'm saying to you, if you look at this expression here, it's basically that expression there. So now, and therefore we can have u here and u squared there. So that integral is transformed as follows: 1 over u plus u squared, and then instead of having this one here, I'm simply going to have du. Simple transformation like this. Now, looking at the denominator, you see that that's a quadratic expression which can be factorized as follows. So we're going to say this is equal to the integral of 1 all over u, open brackets, 1 plus u, and then we have du. This takes us to partial fractions. If you look at this part here, it would need us to do what we call partial fraction decomposition as follows. So I'm going to have to break this one down. I have to decompose 1 over u, 1 plus u. Remember, this is linear and that's linear, so we can say that this is a over u plus b all over 1 plus u. So what do we do? Well, on the right hand side, the lowest common denominator is going to be u, 1 plus u, and then we take u into that. The answer is 1 plus u multiplied by the numerator. So it's a 1 plus u, and then plus u plus 1, or 1 plus u into this expression, it will be u times b. Let me have bu there. Now, on the left hand side, we have 1 over u, 1 plus u, like so. Now, if the denominators are the same and the two fractions are the same, numerators must be the same. Therefore, 1 is equal to a, expand that, a times 1 is a plus au, and then plus bu. Now, let's rewrite this. 1 equals, there I have, if you like, a plus b, u, and then I have plus a. Now notice that there's no term containing u on the left hand side, or if you like, you can write this as 0u plus 1 is equal to a plus b u plus a. Now equating coefficients, 0 will be equal to a plus b and 1 will be equal to a. So a equals 1, and we're saying a plus b equals 0. Now if a equals 1, put 1 here, you're going to get 1 plus b equals 0, and so b equals minus 1. So we have a equals 1 and b equals minus 1. That means that this integral here is transformed by replacing this integrand by an expression which involves these two partial fractions here. Taking us to page number 3. So basically I'm saying that our integral, which integral am I talking about? This one here changes to that I'm going to have 1 in that place and minus 1 there. So now we're saying this integral changes to page 3, taking us to page 3. This integral changes to the integral of, check this, 1 over u plus, if you like, I want to put minus 1 over 1 plus u. And then I have to say du. Why do I have minus here? Because remember what we said, b is minus 1. If you place minus 1 here, this will change to minus. So you have 1 over u because a is 1. 1 over u minus 1 over 1 plus u. Because b, if b is negative, you just better change that sign to minus and have 1 over 1 plus u there, like indicated here, there. Now, let's carry on then from here. So what do we do now? We distribute the integral and du as follows. This will be the integral of 1 over u du minus the integral of 1 over 1 plus u du. And obviously you'll agree with me that this is natural log of u minus natural log of 1 plus u. And then I have to say plus a constant c, because that would be the end of the integral, but we have to revert back to our original variable, which is x. Now, what is the connection? Well, the relationship between u and x is this one here. U is equal to sec x. Now, what I have here is there and there. I must change that to sec x and there sec x, because u is, you can see it clearly here. We don't need a triangle there. U equals sec x. So I just have to replace u by sec x, or with sec x. So this is going to be natural log of sec of x, like this, minus natural log of, there is going to be 1 plus sec x. And I think I need square brackets there because this expression can't be negative. I mean, I need absolute value signs here because this expression, there's a possibility that it can be negative. So we need absolute value to be maintained there. And I have plus c. I'll come and fix that part. So this would be the final solution. But if you want, we can actually write this as an expression with 1 log by using laws of logs. Let me remind you the law of logs I'm focusing on. Basically, natural log of m over n equals natural log of m minus natural log of n. This part here is that part that you see. Therefore, I need this form. So we can rewrite this as, I can rewrite it as, I'll come and fix that. Natural log of, check this out, sec x all over 1 plus sec x, like this, and then I have plus c. That would be my final solution to this integral. Like I said, let me put these back like that. So that would be my final solution. Looking intimidating, but not so much. Just a little bit of partial fraction decomposition involved there, and then being able to see that the derivative of sec is secant, and therefore letting u be equal to sec would actually make the integral look easier, as you can see here. All right, so that will be the first integral and our solution, as you saw. Let's move to integral number 2. Techniques of integration are vast and many, and some of them are very complicated. But remember, we learn mathematics by doing it. So practice makes perfect, as they say. Let's look at number 2. This is integral number 2. And we're basically saying we're to evaluate the integral of 1 over 1 plus e to the power x dx. Now, this is one of those where you just have to, use very clever techniques. If I let u be equal to 1 plus e to the power x, if I differentiate, I'm going to get e to the power x. And I don't have e to the power x in the numerator to go with dx. And therefore, I need to do something. I have spoken about the special one in a couple of videos back. We need a special one here. So integral number 2, it's the integral of 1 all over 1 plus e to the power x dx. And here is the special one that we need. The special one that we need is, check this out, the integral of, I'm going to multiply e to the power minus x, the numerator, and I have to multiply in the denominator by e to the minus x as well. 1 plus e to the power x dx. Notice that is 1. You can cancel that. That's the special one I talk about. But we're not going to cancel it. We expand or remove the brackets in the denominator. So what we have in the numerator is e to the minus x. In the denominator, we have e to the minus x. When you multiply e to the minus x by 1, you get e to the minus x. And when you multiply this and that, the answer is actually 1. Remember that the powers must add. So minus x plus x is 0, e to the power 0 is 1. And we have dx. Rewriting this, we have the integral of e to the minus x dx all over 1 plus e to the minus x. Now you can clearly see now we are in a better position now to apply u-substitution. So if I apply u-substitution now, it will work because I'm going to simply say let u be equal to 1 plus e to the minus x, and therefore du, if you agree with me, is going to be equal to minus e to the minus x dx. Now if you look at this part here, I have e to the minus x dx. I don't have a minus, so I'm going to have to change that sign to positive, and the way I do it is by multiplying on the left by minus 1, on the right by minus 1, and it becomes positive. So this expression here is that expression in the numerator, and therefore the expression in the numerator must be replaced by minus du. In the denominator, I'm going to have 1 plus u. I'm going to have u actually, because this is 1 plus e to the minus x is equal to u. So I'm going to have u in the denominator. So the integral then changes or is transformed to the following integral. We transform that integral to the integral of minus du in the numerator. In the denominator, I just have u. Remember, this is 1 plus e to the minus x, which is actually u. So I must have u there. And in the denominator, I'm going to have minus du as follows. Now, take the minus out because minus 1 basically is a constant. And what do we have now? We have du over u. This you can rewrite as minus the integral of 1 over u du. And you've seen in the previous videos that this is just minus natural log of u. We have to say plus c because, again, this is an indefinite integral. But what is u? Well, going back, u is 1 plus e in the minus x. So this changes to minus natural log of, I'm going to use round brackets now because this expression can never be negative. So we have 1 plus e to the minus x plus c. If you want to respect the order or format in which e to the power x has been presented in the question, this is 1 plus e to the power x. If you want to keep e power x as positive, this minus must go up. So this is going to be natural log of, check this out, 1 plus e to the minus x power minus 1 plus c. What does this mean? Well, taking us to page 6, we're basically saying that is equal to natural log of reciprocating this basically, because that's what power minus 1 is. So this is going to be 1 all over 1 plus e minus x like so plus c, multiplying by e minus x in the denominator and the numerator. I mean e power x in the numerator and the denominator. What we have is natural log of e to the power x times 1 is e power x all over e power x times 1 is e power x times e power minus x is 1. What are we saying? Plus c. So this would be our final solution with positive what? Positive e with positive x. In other words, e power x, not minus x, because the original question here has 1 plus e to the power x, and we just wanted to maintain that. Otherwise, this one here is also accepted as a solution to this question. You would actually stop here if you wanted, but otherwise this would be another equivalent form of the same solution. All right, this is the end of this video because this was, I only had 2 integrals to look at in this one. Many more integrals will come, but otherwise I want to stop here. If you're new to the channel, please don't forget to support us by subscribing and giving us feedback, because your feedback is absolutely important. All right, I'll see you in the next one.